Alright, hello everyone. So today we're going to use a half angle identity to find the cosine of 7 pi over 12. Yes, so it's a trigonometry or pre-calculus problem. Alright, and basically what you're going to be using is these half angle identities, which I've listed here. And cosine of theta over 2 is how we would say that, is equal to plus or minus, that's what that plus or minus here means, the square root of the quantity 1 plus cosine theta all divided by 2. The sine of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 2. And then finally, the tangent of theta over 2, there's two versions of this identity. Sine of theta over 1 plus cosine theta. And then we have 1 minus cosine theta over sine theta. Okay, that's the second version. So we'll be using that cosine formula. And let me start off by writing we're trying to find the cosine of 7 pi over 12. Now, to use that identity, here's how that works. You're going to look for theta, and theta is what you take half of to get that 7 pi over 12. Okay, so what angle when you divide it by 2 gives you 7 pi over 12? Now, if you're good with radians, you might have just figured that out. In fact, you can use an equation here. If you multiply both sides by 2 with that angle, you would get 7 pi over 6. So that's the angle that you're working with. Now, if you don't see that or you don't feel comfortable with what I tell people, because often you're looking at radians and people aren't familiar with radian measure all that much other than the typical angles that you see on the unit circle, I say, okay, why don't you convert this to degrees for a second? So 7 pi over 12 times 180 over pi. Pi's cancel, 12 goes into 180 15 times, 105 degrees. So you're looking for the cosine of 105 degrees. So 7 pi over 12 equivalent to 105 degrees. So there you would ask yourself, what angle when you divide by 2 gives you 105? Well, that's 210. The only issue, though, is that because we're working with radian measure, I need to work with radian measures here as well. So, sorry, theta is 210. So your angle here is going to be the equivalent, or 7 pi over 6. Okay, so those are a couple ways of getting the actual angle. And what you do is you're going to take your, let me erase this, your angle that you just found, which was 7 pi over 6, and put it over 2. Okay, and that's one of the big complications with these types of problems. Let me just redraw this here. So you take the angle that you divide by 2 to get 7 pi over 12, or whatever that is, and just write it out as such, 7 pi over 6 over 2. Now, the difficulty is getting that angle a lot of the time. The other difficulty is this. If you go ahead and look at the formula now, plugging in that information into the identity, you got that plus or minus, and then this says take 1 plus the cosine of 7 pi over 6, so it's the angle, again, that you divided by 2 to get to that point, which is 7 pi over 6. But see, you can't have both the plus and the minus. These are what we call trigonometric functions. Like for every one input, you only have one output. So it's either the plus or the minus. So how do we determine that? Well, it depends on the angle and the trigonometric function that you're working with of the original. So this was 7 pi over 12, or 105. That's in the second quadrant. And cosine in the second quadrant is negative. So in reality, I'm not going to choose the plus, I'm going to choose the minus. All right, so then all you need to do at this point is to find what the cosine of 7 pi over 6, which is a negative root 3 over 2. So I'm just using the unit circle at that point. Let me make the square root a little bigger. So all we did was just replace cosine 7 pi over 6 with that value. And technically speaking, you can leave it this way. It's an answer. However, you will see this, usually this type of problem simplified. Because technically speaking, inside the radical is a complex fraction, or fraction over a fraction. So we try to simplify that. And one way of doing that here is by multiplying both the numerator and denominator by 2. Okay, and 2, because that's kind of like if you looked at all the well, there's the fractions, put it that way. The common denominator would be 2. And what I would do is I would distribute the 2, so you get 2 minus root 3 over 2 times 2, all over 2 times 2, 4. you get minus 2, and then these 2's cancel, you get 2 minus square root of 3 over 4. But the square root of 4 is 2, so I can take that out. And this is what you get, okay? And that is your answer to the problem, in a more simplified form. Doesn't look nice. Square root of quantity 2 minus root 3, it's like a double radical there, all divided by 2 with a negative on the front. Yeah, these are not pretty answers a lot of the time, okay? So again, you identify which of those identities you're going to use, and which is often not the case. Is the difficult part, because if you're told to use a half angle identity, then you know what, it's one of those three usually. And from there, the hard part is usually just finding the angle that you're taking half of to find the angle that you're finding the trig function of, and then plugging that angle in. And then the second difficulty arises from figuring out the sine. And how do you do that? You look at the trig function and the quadrant the original angle is in, and there you go. All right, well, I thank you so much for your time. Hope this helps.